This video is over lesson 92, areas of rectangles with variable dimensions and product of binomials, and it is for my pre-algebra classes. So ladies and gentlemen, first of all, to find the area of a rectangle, remember that we use the formula A equals LW. So finding the area of a rectangle really means multiplying two numbers together. For that matter, a product of binomials, well, a product again is multiplying things together. So the theme of today's lesson really is multiplication. And since it is multiplication, we're going to go ahead and start with a multiplication problem. We are going to take a look at 42 times 67. However, I don't want you to use your calculators, and I don't want you to do this the normal way, using the normal algorithm that we've learned for multiplication. Today we're going to kind of come at this from a different direction, specifically using rectangles. And to help us with this, I want to break this apart a little bit. 42 is made up of a 4 and a 2. So what this is communicating here is I have 4 groups of 10, which really is 40, and then I have 2 groups of 1, which is really 2. So 42 is just a much simpler way of saying 40 plus 2. Likewise, and no, I don't need the dot there between the two parentheses, but I'm just, since I have a dot there, I'm putting a dot there just to emphasize it. And so, but anyways, 67 then likewise is 6 groups of 7, or 60, and then the 7 in the ones place means 7 groups of 1, or just 7. So these really are the same problem. So ladies and gentlemen, if I now imagine a rectangle, I'm going to go down 4 spaces here, and then go down a little more. I might go a little more than, a little closer to halfway there. So, and then I'm going to come across here. I want to go across about the same distance, and then do that half over again, and then a little extra. And so your rectangle should look roughly like that. And I'm going to split this up. And I chose 4 spaces there because I want this here to be my 40, and then down here this will be my 2. So that if we put this together, 40 and 2 is 42. And so going this way then, I'm going to go a fair bit this way, and I'm going to have my last little bit here cut off. So this will be my 60, and then this little piece here will be my 7, so that this is 67 all the way across. So if I find the area of this large rectangle, then I've found the product of these two numbers. But because we've broken this up into its pieces, what I can do here is I can just find the area of each piece and then add them all together. So out here, this big section here is just going to be 60 times 40, or 40 times 60. So let's go ahead and write 40 times 60. Well, 4 times 6 is 24 with 2 zeros at the end. 2,400. Coming over here to this strip right here, and I'm just going to draw a line out there since it's a little small to write in there. This would be 40, and that's 7, so 40 times 7, well, 4 times 7 is 28, with a 0 at the end. Okay, down here, I've got 60 across and 2, so 60 times 2 is 120. And then finally, for this little guy right here, well, this is 2, and that's 7. 2 times 7 is 14. So therefore, if I add all these up, 2,400, 280, 120, and 14, add those up. 0004 is 4. 8 plus 2 is 10, plus 1 is 11, carry the 1. 1 plus 4 is 5, plus 2 is 7, plus 1 is 8. And then, well, 2 and nothing is 2. So the answer to this multiplication problem is 2,814. Now, ladies and gentlemen, just to draw a quick connection here, if we were to do this using the normal algorithm, so 42 times 67, 4 times 2 is, or excuse me, 7 times 2 is 14. So there's my 14. And then 7 times 4 is 28. But since this is in the tens place, this is really 40 times 7. So it'd be 280, which I put the, instead of putting the 8 down, I add the 1 to it, which makes it a 9. So this is really just my 14 and my 280 put together. And then I put a 0 down for a placeholder. 6 times 2 is 12, but this is really a 60. So 60 times 2, notice that the 2 goes here in the tens place, so the 1 would go in the hundreds place. Well, there's my 120, except for I'm going to carry the 1. And then 6 times 4 is 24, but this is 60 and that's 40, so it's really 2,400. But then I add the 1, which makes it look like a 25 there. So we have all 4 of those pieces just written in 2 lines. So our algorithm that we learned years ago really just takes this and speeds it up. So, and of course, for 1, carry the 1, 8, 2, same answer. So when you're doing this, do it this way, guys. But we've got a point for this, for what we're doing today. So this is a method you can use. I don't recommend you use it, but you can. Okay. Looking at it from another perspective, I want to take a look at 2.5 times 3.5. So likewise, I'm going to split this apart. Mixed numbers are kind of a funny thing in mathematics because they're really about the only place that we see implied addition. So 2.5 really means 2 plus 1/2. And then 3.5 likewise means 3 plus 1/2. Oop. Got the 3 stuck in my head there. 3.5. There we go. So now normally we would just change these both into improper fractions and we'd multiply them, and that's very nice for doing these. And that is what I want you to do in general. However, we can use, and I don't recommend that you do it here, we can use a rectangle. I'm going to go 1, 2, 3, 4, 5. And then we'll go about the same distance and a little bit further. So this time I'm going to cut off this bottom half. I'm going to call this up here 2, and I'm going to call this 1/2, and it's not, doesn't have to be perfect there. And then over here I'm going to kind of do likewise. And so I'll have my 3 and my 1/2. So just like last time, so now this side of the big rectangle is 2.5. This side is 3.5. So we find the area of the whole thing. Then we've found the product of those two numbers. So in here, 2 times 3 is 6. 2 times 1/2 is 1. 3 times 1/2, so half of 3, would be 1.5. And then finally here, this is 1/2 and 1/2, so half of 1/2 is 1/4. So if we add these numbers up, we'll get the area, and we'll get the product. So 6 plus 1 plus 1.5 plus 1/4. Start right in the wrong spot there. All right, add these up. Well, 1/2 plus 1/4, for today's purpose, we know what that is. So 1/2 is really 2/4 plus 1/4 is 3/4. And then 6 plus 1 plus 1 is 8. And if you were to change these both into improper fractions and multiply them together, you would go ahead and confirm that this actually is 8 3/4. Okay. So using the rectangle is a way of doing this. Again, I don't recommend that you actually do it this way, but it will work. And the reason why we're going through all this, ladies and gentlemen, is because I now want to make this real general. And I want to consider what happens if I have anything where it's one thing plus another times one thing plus another. Now, these are called binomials. These are called binomials. They have two terms. Remember, terms are separated by addition. So technically, if we rethink these like this, we change our mixed numbers into binomials. Likewise here, if we rethink 42 and 67 like this, we turn them into binomials. So I want to know just in general, what will this end up being anytime we got a binomial times a binomial? And so again, I'm going to make a rectangle. And I'm just going to split it. A plus B and C times D. So first up, this area right here is going to be A times C, so AC. This area here is going to be A times D, so AD. This area here will be B times C, so BC. And finally here, B times D, BD. So what we see here is that if we now add these up, we're going to get the area. The only thing here is none of these are like terms. Which means that in this form, we can't combine them at all. But I don't really need to combine them right now. Actually, what I want to look for is a shortcut for this. I want to look for some way that I can start to leave these rectangles behind. Some way that I can speed up the process without having to draw that every single time. So let's consider where we got these things from. So AC. So A and C, if we take a look at them, one is from each binomial, but what they have in common is they happen to be the first term in each of their respective binomials. So we're looking at AC there and we're thinking, okay, those are the first terms in each of the binomials. We move on to AD, okay, A and D, so again, they're one from each binomial. A is over here, it's the first one, D is the second one, so they don't have that in common, they're not both first or both second. But if we look at the problem as a whole, we find A and D on the outsides of this problem. So if we call that the outsides, so the first outsides, so BC then, well, if AD is the outsides, BC must be the insides, and then BD, well, B and D are both the last term. So just like A and C are the first term in each binomial, B and D are the last terms in each binomial. And so, ladies and gentlemen, what we discovered here is a little acronym we use for multiplying binomials. It's the acronym FOIL. So F stands for first, O stands for outside, I stands for inside, and L stands for last. So multiply the first term in each binomial, multiply the outside terms of the entire problem, multiply the inside terms of the problem, and then multiply the last terms in each binomial. Add those all up, and we've got our answer. So I'm going to flip over now, and we're going to see if we can go ahead and use FOIL to help us speed up this process. So let's say we have x plus 2 times x plus 4. And this is really where FOIL comes in handy. Again, if we go to the front for just a moment, do this the normal way, okay? I would not change 42 and 67 into these and then FOIL them. Just do it the way that you learned how to do it years ago. Same thing here. Change these into improper fractions. I would not change them into binomials and then FOIL. So really, FOIL is useful when we end up with things like this. We end up with things with variables. So if we FOIL this then, I'm going to start with the f. So f first. So the first term here is x. The first term here is x. X times x is x squared. Plus the outside terms multiplied together. So going on the outside of the problem, I have an x and I have a 4. So x times 4, we put the 4 in front, 4x. Plus, next up is I for insides. So if those are the outsides, then these are the insides. So 2 times x is 2x. And then finish it off, FOIL the L. So if these are the first terms in each binomial, then these are the last terms. So 2 times 4 is 8. And there we go. Didn't need my rectangle. However, what I do need to do is I do need to combine like terms. So this is an x squared term, this is an x term, an x term, and a constant term. So I can combine these two x terms. Therefore, I'll get the answer x squared plus, now 4x plus 2x, that's like 4 bananas plus 2 bananas. That's a total of 6 bananas. So this will be 6, and it's still x. When we combine like terms, variables do not, or excuse me, exponents do not change. It's just that number out front that's being added or subtracted. Exponents do not change when we combine like terms. Okay. And then don't forget your plus 8. And so this right here actually would be our answer. So with that being said, we are now going to take a look in our books. If you'd open up to page 620, please. And we're going to take a look at the practice problems. So pause the video if you need to in order to open up to your book. So refer to this rectangle to answer problems A and B. So A, what is the area of the rectangle? Make a sketch and check by multiplying. So what is the area of the rectangle? So, well, let's check it out. So A, I'm going to do it the algebraic way, and then I'm going to do it the geometric way. The geometric meaning using the rectangle. So first of all, the algebraic way. A for capital A for area. Well, area is length times width. So the length of this rectangle is x plus 4. And then the width of it is x plus 2. Which we can see is actually going to be very similar to what we had up here. Excuse me. The only difference here is my firsts are still going to be x squared, but my outsides now will be x times 2, so we'll have a 2x, and then the insides will be the 4x. And then out last will still be 4 times 2 is 8. And so this will actually simplify the same way, which should make sense because commutative property of multiplication tells me I can switch these two around. So it's like that, and it should come out with the same answer. So there's my area the algebraic way. So now the book is asking me to make a rectangle. And so I have x, and I have x, so x plus, well, I'm going to put x plus 4 up here. So x plus 4 and x plus 2 down there. So if we find our areas, I've got x times x, which would be x squared. I've got x times 4, which would be 4x. I have x times 2, which will be 2x. And then I have 2 times 4, which would be 8. So sure enough, if I make my sketch here, and I go ahead and I now add all these together. So x squared plus 4x plus 2x plus 8, sure enough, is x squared plus 6x plus 8. So B, what is the area of a square with side length x plus 4? List and explain each step you use to find your answer. So, ladies and gentlemen, we're going to start with the area of a square. So A equals, well, s squared. So s in this case is x plus 4. So list and explain each step here. What we're doing here then is the area formula of a square. And then I'm going to change this to x plus 4 times x plus 4. And so what we're doing here is we are expanding. So expand the square. And now we're going to go ahead and use our FOIL. So first I have x and I have x, so x squared. Outsides, x times 4 is 4x. Insides, 4 times x is also 4x. And to finish it off, the last 4 times 4 is 16. So FOIL. And now last thing, combine like terms. 4x plus 4x gives me 8x. Now this is an x squared term, that's an x term, that's a constant. None of those are the same, so we cannot do anything further. So what's my reason here? Combine like terms. All right, and C. Find the product of x plus 2 times x plus 5. Depict the product with a rectangle. So x plus 2 times x plus 5. So I need to use a rectangle here to find this, they're telling me. So I'm going to just come on down. I'm going to make that x and make that 2. I'll make that an x, and then I'll go whoop, a bit over there for my 5. So x plus 2, x plus 5. In here I have an area of x squared, x times x. Over here I have x times 5, which would be 5x. Here I have 2 times x, so 2x. And then finish it off, 2 times 5 is 10. And so then this would be x squared plus 5x plus 2x plus 10. Combine your x terms, combine the like terms. So 5x plus 2x is 7x. And there's my product. D. D through K, it just says to expand. So I'm going to just go ahead and expand, which means use FOIL. So x plus 1 times x plus 3. Sorry, I lost track of my page there. So first, x times x is x squared. Outsides, x times 3 is 3x. Insides, x times 1, or 1 times x, is just plain old x. And then 1 times 3 is 3. I'll put an equal sign there and just finish this up. So combine like terms, x squared, or 3x plus x, well that's 3x's plus 1 more x, So 4x's total. And there's the expanded form. Oops, I just realized you couldn't see what I was writing there. So just to go over what I did there, I had this. So first was x times x. Outsides was x times 3, so 3x. Insides was 1 times x, so that's just x. And then out last was 1 times 3, or just 3. Then I combined like terms, so I combined my 3x with my x. So if you have 3x and then add on another x, that's a total of 4x's. All right, E. E, I have x plus 4 times x plus 7. And so I'm going to get, first will be x times x, or x squared. Outsides will be x times 7, so 7x. Insides will be 4 times x, so 4x. And then your last will be 4 times 7, or 28. Combine like terms, so I can combine the 7x and the 4x to give me 11x. Still have an x squared till I have a 28. F. X plus 3 squared. So first, I'm just going to expand the square and then FOIL. So first will be x times x, or x squared. Outsides will be x times 3, so 3x. Insides will be 3 times x, or 3x again. And then last will be 3 times 3, or 9. Finish it off. Combine your 3x's, so 3x plus 3 more x gives you a total, it's plus, so 3 plus 3 is 6x. All right. We're going to go ahead and move on actually to letter H. We're not going to do all of these today. So moving on to letter H, I have x plus 8 times x minus 3. Now the thing with this one is we need to remember that when we see a minus, we need to think of this like a negative. So this is really like a negative 3 right here. So if we go ahead and multiply first, x times x is x squared. Outsides, x times negative 3 will be a negative 3x. 8 times x is just normal positive 8x. But then the last will be 8 times a negative 3. Well, 8 times 3 is 24, but the negative will tag along to make this a minus 24. So now when I put this together, I'm still going to have my x squared, but now I've got a negative 3x plus a positive 8x. So remember, when they have an opposite sign, we subtract them, so 8 minus 3 is 5, and since this is a positive, it would be a positive 5x. And then minus 24 still. All right, I'm going to come over here and I'm just going to split the page right there. Let's go ahead and do I. So we have x minus 5 times x plus 2. So first, x times x is x squared. Outsides, x times 2 is 2x. Insides, a negative 5 times x will be a negative 5x. And then to finish it off, last, a negative 5 times a positive 2 is a negative 10. Simplify that, I get x squared. Now a positive 2x and a negative 5x will make a negative 3x altogether. And then minus 10 still. So if we take a look at J, So likewise, first x times x is x squared. Outside's a negative 2 times x is a negative 2x. Inside's positive 2 times x will be a plus 2x. And then last, a positive 2 times a negative 2 is a negative 4. Combine like terms, a negative 2x and a positive 2x. Well, negative 2 plus positive 2 is 0. Remember, though, that we're taking this number and we're multiplying it with x. So 0 times x will just be 0 altogether. So the x terms are actually just going to disappear here. And that'll leave you with x squared minus 4. All right, and last one, k. So with letter k, we got 20 plus 2 times 20 minus 2. Now, generally, I would tell you to just go ahead and follow the order of operations here and do 20 plus 2 is 22. 20 minus 2 is 18, so it's really 22 times 18. But this time, let's go ahead and follow the FOIL and see what happens. So first will be 20 times 20, that's 400. The outsides will be 20 times negative 2, so that'll be a negative 40. Insides will be a positive 2 times 20, that'll be a positive 40. And then last will be a positive 2 times a negative 2, so negative 4. Well, negative 40 and positive 40 really are just going to cancel each other out. So this really is just 400 minus 4, or 396. And that, ladies and gentlemen, is our lesson.